gentlemen. Can you all hear me? Fantastic. Good afternoon all. My name is Olaf Diegel, and first of all, I'd really like to thank you all for spending your valuable time this afternoon to hear me talk a little bit about 3D printing, which is something over the last few years I've become fairly passionate about. So I thought maybe just before I start talking about 3D printing, I'd give you a little bit of background about myself and where I come from. So this is the story of my life. I've lived just about everywhere. I'm a citizen of the world. Born in New Zealand, grew up in Canada, South Africa, Japan for a while, back to New Zealand, and now Sweden. So I now live here for 2 months and a few days. So great to be here. Just to give you a little bit of background about me growing up. So I studied engineering, but before studying engineering, it's always good to show some embarrassing pictures. We were a Sound of Music type family, so we were 5 kids in the family, and we all grew up playing music. And that'll come back later as a theme when I start talking about my 3D printed guitars. I was so geeky that while I was studying engineering, I was also in a medieval music band. So it shows you the 2 extreme sides of the spectrum, doing the hardcore technology. I studied electronics. Never really worked in electronics, but I studied it. And at the same time, we were making instruments in my garage and playing very strange music. But it wasn't only strange music. We also played, I did a few stints in rock and roll bands, so I was cool as well. In terms of my work background, I'm a relatively recent academic, probably about 12, 13 years as an academic. Before that, I was working in product development, developing all sorts of products for many, many different types of companies. So I did a lot of work working for lighting companies, developing lights for theaters, museums, displays around the world. And on Sunday, I was at the History Museum in Lund, and I saw you have some of my spotlights. So even in Sweden, you have very good taste in lighting. So yeah. Developing medical products, home health monitoring, blood pressure monitors, that sort of stuff. While I was doing that, I was doing it, but I didn't know why or how I was doing it or the right way of doing it. And that's when I went back to university and I studied first project management. And that I really enjoyed, and I then did a PhD in product development. And that got me interested in how do we develop products better and faster, products that meet the customer's needs better, and being able to get to market quicker. If you can get to the market 3 months ahead of the competition, 6 months ahead of the competition, that gives you a huge advantage. And that's when I got very interested in tools like CAD, computer-aided design, as a tool to help you design better. And then a logical extension of that, you've now designed it in the computer. Suddenly you've got these magic technologies called 3D printing that allow you to instantly go from your idea to a manufactured part. And that's what we're talking about today, really 3D printing, some of the application, what it's being used for today, and a little bit about where it's heading in the very near future. So today the talk is not a technical talk, it's more about what 3D printing is and what it's being used for today and where it's heading in the very, very near future. So crash course in 3D printing or additive manufacturing, the old way of making anything. So if I wanted to make a bust of my head, which I think is a very good marketable product and everybody would want one in their living room, you start with a block of marble and a chisel and you cut away all the marble until you're left with a head. So that's called subtractive manufacturing, because you're removing material to make the part you want. The more modern way of doing exactly the same thing is on a CNC machine. You have a block of material, and instead of a hand chisel and a hammer, you have a cutter that automatically is programmed to cut away the material you don't want until you're left with the head. So subtractive manufacturing. And today, 99% of products are still made using some form of subtractive manufacturing. Either you make the part directly, or you make a mold, which is a block of metal, and you cut away parts of it, and you inject plastic into it, or cast metal into it to make your parts. So still today, this is the main way of manufacturing products. Additive manufacturing is relatively new. Now, when I say relatively new, it's over 30 years old, but you start with a virtual computer model. So it's a virtual model that you've designed in 3D on the computer, and the 3D printer slices it up into very thin slices and then prints, quote unquote, one slice on top of the next, on top of the next, on top of the next. So layer by layer by layer by layer, it builds up your part. The different technologies use different ways to print the slice. They use different materials and different technologies to do it. But if you think about the old terrain maps, we used to make terrain maps of the village around you, you'd have slices of wood or slices of cardboard cut to the right thickness and the right profile, and you glue them one on top of another to make a 3D model. That is the principle of 3D printing. But of course, the thinner you make the layers, the better the quality of the parts you make. So the next slide I won't really spend any time on. Very broadly, the technologies are based on 3 different types of material. So the first one is extrusion-based, or solid-based. The little machine you'll see just outside there works on that principle. Essentially, think of it as a hot glue gun. And with your hot glue gun, you take the slice of the model and you trace it out with your hot glue gun, drop it down, take the next slice and trace it out layer by layer by layer, you build it up. So for those of you who didn't see it on the way in, on the way out, you'll see just outside the doors is a little desktop 3D printer that's printing out a little statue now. Next technology is liquid-based. It's a liquid-based resin. Spread a layer of the resin and a UV laser cures it where it needs to. So it scans the resin. Wherever the laser hits the resin, it hardens. The rest of it stays liquid. Drop it down, next layer, and again layer by layer by layer. I'll pass this little chess piece around. When it goes around, have a look at the inside. You'll notice there's a spiral staircase going up the inside, and then if you look through the windows, you'll see there's like a double helix of DNA going up the inside. And try to imagine how that got in there and how long it would take you to make it the old-fashioned way with tools. It's probably impossible. And of course, the final category is powder-based, where you spread a layer of powder. It would be plastic or metal, and a laser melts the powder where you need to, drop it down, another layer of powder on top, laser it, drop it down. Now, when you see these technologies in operation, they're actually amazingly simple. When you try to explain it without seeing it, it sort of hurts the brain a bit to think about how they do it. But it's actually very simple. It's that layer by layer by layer manufacturing method. So, as I said, this has been around for over 30 years. I started probably in the early mid-90s, I started using it as a prototyping technology. So I had an idea for a product. Before I commit 100,000 or 500,000 crowns to going into production, I make a prototype to make sure my idea is 100% right. In the last 3 to 5 years, the technologies have evolved to the point where you can use them not just for prototyping, but for manufacturing the real product. And that is quite a radical change in how we do things. So that's what we're talking about today. So from here, pretty much all the slides, I've tried to divide them up into the advantages that 3D printing has over conventional manufacturing. There's about 5, 6, 7, depending how you count them, advantages that it gives you over the conventional technologies. Now, one of the important things is, as I'll show you later, we have a whole bunch of these 3D printers here at the university, and we're going to be getting more and more over the next few years. Probably about 60–70% of what I see students printing is a little square plate. And you say, well, why are you 3D printing it? There's 100 better ways of making it quicker and better. So one of the key messages to take home with 3D printing is it's a good technology if you use it for the right reasons. And probably this is one of my take-home messages for today. The first thing, there's a lot of press that says 3D printing is going to take over manufacturing. Manufacturing as we know it is dead, it's all gone. I don't think that's the case, or certainly not in the very near future or even the medium future. I think 3D printing is a certain technology that for certain applications, and if used the right way, has got incredible advantages over conventional manufacturing. So the key is to identify those. So the next sort of 20 or so, 30 slides are just examples of those advantages that it does give you and examples of how it's being used today. Now, pretty much all the products I'm going to show you today are things you can go and buy today online. So these are not prototypes, these are the real things. So the first advantage we talk about is complexity for free. One of the big advantages of 3D printing is the more complicated a part is, the more suited it is to 3D printing. Typically, if a part is very simple, there's probably better, more economical ways of making it than 3D printing. This is a very nice example of it. It's sort of a amoebus toroid strip of some kind. When I pass it around, have a look at the intricacy of it. Have a look at how complex it is. And if you shake it, you'll see there's even a loose ring on the inside. And again, try to imagine how they got in there. But that's a good example of a part that is well suited to 3D printing. You just could not manufacture that using conventional technologies, any conventional technologies. So that's a nice example of what complexity for free is. One of the first examples I use is jewelry. Now, the reason I use jewelry, most of the jewelry you see here, you can go onto sites like Shapeways, and you can buy most of this jewelry for between 100 kroners to maybe 500 kroners. So this has made it quite accessible to regular people to be able to buy 3D printed jewelry. And a nice little example of this is from an artist called Bathsheba Grossman, and it's a little gold-plated steel pendant. But again, it shows that advantage of complexity for free. It's a model that's similar to those ones you see in the middle there. Very, very nice examples of being able to do things that are probably impossible or very hard to manufacture any other way. Art and design objects. Artists absolutely love this technology. In the past, artists would design something, they'd sketch it up, they'd go to the engineering shop and say, please, can you make me one of these? And the engineers would say, don't be stupid, it's impossible. You can't make it. Suddenly, they're given this technology where if they can conceive it and get it into the computer, they can make it. That is incredible. Now, I hate to say this about engineers, because I'm sort of one of them, but engineers tend to be quite boring about how they use these technologies. They make a few gears, a nice mechanism to show the mechanism. Artists come to the lab and say, can I do this? And we scratch our heads a bit and say, ooh, I don't know, but we'll try to figure it out. And they really push the boundaries of what this technology can do. And that's why artists are so great to work with. And you see some very, very nice example. Joshua Harker, the guy in the middle, he used crowdfunding. So he wanted to make those skulls and sell them. And crowdsourcing, so Kickstarter is a new way of raising funds where if you have a project and you want to raise money for it, you put it on Kickstarter. Now, he needed somewhere around $7,000 to do a production run of these skulls to sell. Within a week, he'd raised 76,000 US dollars. Now, it just blows the mind how keen people are on 3D printing and how good it is as a tool to raise money very, very quickly. This is a really nice example for marketing. It's a bit hard to see on the top picture. This is Onitsuka, the Japanese company that makes ASICS running shoes. And as a marketing campaign, they wanted to do a Japanese city in a shoe. And you can see some incredibly complex detail. I'll show you on the next slide, even more complex. So this is the level of detail you can see there. You've got cars, you've got signage, you've got billboards. So this was a marketing campaign. It was incredibly successful. So Onitsuka did very well out of it. And the campaign went viral. And it got so popular that people started to say, oh, I want some of those. So Onitsuka then started to make memory sticks and little running shoes, silver shoes, based on the marketing campaign. And it kept getting more and more viral, getting more and more popular. And they eventually started making a range of shoes based after the marketing campaign. And it's one of the only examples where I know where a marketing campaign has transformed into a product rather than the other way around. So again, it just shows that 3D printing can be used to think in different ways and allows you to do things you wouldn't necessarily have done the old-fashioned way. Designing for additive manufacturing. So what you're seeing on the top left there, particularly in that middle picture, is a bracket on the Boeing Dreamliner. It's one of the door brackets. They now 3D print quite a few parts on aircraft. Now currently it's none of the vital parts, but things like the ducting on a lot of the aircraft is 3D printing because these are incredibly complex shapes. But that door bracket is a very, very good example. You see on the top there, that's the way it would be manufactured conventionally. Just below that, you see a 3D printed version of it where they've removed more than half the material, yet kept the same strength and the same rigidity. So suddenly you can lightweight all your parts, and you think about the implications that for automotive and aeronautic applications. Here's a little example of that. I need to make sure this comes back because my keys are on it. It's a little bottle opener. This takes 1/15 of the material that the solid machine billet bottle opener would take. So an incredible reduction in the amount of material and the weight of the component. They've tested these at 300 kilos to break those. So it's called topology optimization, which means redesigning your part to minimize the amount of material, but maximize something. It could be rigidity, it could be flexibility, various factors like that. Now, what we need to do when we think about 3D printing is not designing in conventional ways, but designing in new ways for additive manufacturing. If we do that, suddenly we've got huge things to gain from 3D printing in general. The next big area of advantage that 3D printing gives you, mass customization. So currently we buy products that are manufactured where it's one size fits all, where you buy a product and it more or less works but is not tailored to your needs. Why can't we buy products that are made to fit us perfectly? And probably one of the big things with 3D printing is whether you make 10 exactly the same or 10 completely different, it doesn't affect the price. With conventional manufacturing where you're making a tool, if you make any small change, that costs you a lot of money. So suddenly you've got the freedom to make every product custom made for the customer. And the best example I can think of that is medical. Hearing aids. About 97% of the world's inner ear hearing aids are 3D printed. We don't even know that. But they put some silicon in your ear, pull it out, laser scan it, and they've now got software that'll automatically shell it out, leave the space for the electronics, and print you out a hearing aid overnight with full tracking with numbers on it so they can trace it back to you. I mean, that is incredible. That is a really nice example of mass customization being used in a real way. Ala Ortho at the top, they do hip replacements out of titanium. And as it happens, they do them on Arcam machines, which is a Swedish company that makes some very nice machines. Some examples of that. This is a bit of titanium bone replacement. So it's a titanium mesh that you print out, and if you've got a broken bit of bone missing, they print it out in the shape that it needs to be, implanted, and then the bone grows into it. And then we have a little vertebra, also printed in titanium. So again, nice examples of how to use it for mass customization. Now, as it happens currently, Ala Ortho don't do customized hip replacements. There have been quite a few examples of that in the past, but they tend to do one size fits all. Now, you'll notice on the hip replacement, the inside, which you can't see, is a smooth ball joint because you need the hip bone to rotate on it, but the outside is porous, so that when you implant it, the bone grows into it. It's called osseointegration, which means, as I understand it, if you have a hip replacement, over the course of your life, you're going to need 2 or 3 adjustments. As it goes loose, they have to go in and retighten it all up. With this technology, because your bone grows into the hip replacement, you don't need any adjustments afterwards. And that is quite incredible when you think about it. The next little example is actually one from New Zealand. It's a fairly recent one. Again, a bit dark on the slides here. That is a dog jawbone. And this was the dog who had cancer of the jaw. They 3D printed a titanium jawbone replacement, implanted it, and the next day the dog was eating. Now that is an incredibly feel-good story. And this was done in New Zealand by some engineers there. I've actually got one of these jawbones coming in my container, but it didn't quite make it in time. But it's an impressive piece. Again, that porous titanium in there. Very, very impressive. But you think about it, 24 hours the dog had recovered enough to eat. And that is, that blows the mind when you think about it in those terms. Another example from New Zealand, from Victoria University, Cortex. And this was a student who had the idea of doing 3D printed casts. And the general idea is you get an X-ray to see where your arm is fractured, you do a scan of the outer arm, and you print out a cast that fits you perfectly and has reinforcements in the spots you need it to support the fracture. And here's an example of his first SLS prototypes on his arm. Now this was done as an industrial design project. So as it is there, it doesn't quite work. But it's only a small step now to get it to the next level, to get it to work and get it into a commercially producible system. And there's now quite a few people around the world working on this same idea to do custom-made cast and prosthetics for people who need them. I suppose because of my background in lighting, and I did a lot of work designing lights over the years, I've got an interest. And again, these are nice examples of impossible shapes that would be nearly impossible to make any other way. But the one I particularly like is the one in the middle. It's a light called the Tuber by a British artist called Lionel Dean. On his website, it's called futurefactories.com. You can go onto his website, and on his website, he's got an animation of that light in the middle continuously morphing and twisting and changing shapes. And when you see a shape you like, you say, stop, buy now, and a week later you get a light that nobody else in the world has got the same one. So it's a bit gimmicky, but it's a really nice example of that mass customization of unique products for each person. So very, very nice example of that. And of course, the ultimate mass customization is printing people. Mini-me's. Right through from little wedding cake bobbleheads to little R2-D2s or Star Wars figurines with your own head on it, to there's now several countries around the world where you've got 3D photo booths, where instead of doing a 2D picture, you stand in a booth and 7 seconds they'll do a full body scan, and unfortunately they don't print while you wait. But a week later you get a little package in the mail with a colored mini-me in it, which is a very, very nice example. Disneyland now, you can now take your kids to Disneyland, they'll scan your children's face and they'll print out a Cinderella doll with your child's face on it. Now that's quite cool when you think about it. It's not good for society or to save the world, but it's a nice example of toys your kids might form a bigger attachment to. Now, the Japanese often tend to take things to a bit of an extreme. So here's an example from Japan. It's actually the example based on a doctor from Brazil who does a lot of work with premature fetuses or fetuses that have a problem. And from ultrasound information or CAT scans, he'll print models of the fetuses so the doctors can actually plan their surgeries. So a very, very good application, very nice application. The Japanese took the same idea, and I think it's called Shape of an Angel, where they thought our mothers are going to want little 3D prints of their babies before they're born to put on a keychain or a necklace. So not entirely convinced about the market viability of the idea, but it is a nice sort of idea. But it is really the ultimate mass customization. Everybody's different, therefore it's a good example of how you can do these things. This is another interesting area, being able to make complete product assembled in one go. And this is always a very nice example. So it's called the Brain Gear. It's a model you can download from websites like Thingiverse. It's a free download. You can print it out. That entire ball with all the gears on it is printed in one piece. So it's not 10, 15 pieces all assembled afterwards. It comes out of the machine assembled and ready to go. And there are lots and lots of very, very nice examples of that. I'll show you the one guitar shortly, the steampunk guitar with all the gears. Again, printed in one piece. So it's a very, very nice way of showing how you can think differently. So a product that might have been made with 15 or 100 components, suddenly you can make it out of 1 or 2 or 5 components. Less assembly required, less things to go wrong and break down. So the first example from this complete products area is with fashion and being able to do 3D printed entire garments. So this little bit of chainmail is the same pattern as the top dress and the glove on the top. Again, all of this is printed in one piece. Now try to imagine making that by hand, joining all the little rings together to get them all joined together. That is quite incredible. Bottom left is Dieter Von Teese. It's this Hollywood starlet, and again, they did a 3D printed dress. But the one that's particularly interesting is the bottom left one from Continuum Design, which is the first 3D printed bikini. It was done about a year and a half ago, so it's not that new anymore. The reason it's interesting is not because it's a bikini, but because of how they've done it and how they've done it differently. Most of the other fashion things that have been on the market so far have been done with essentially chainmail, so links that are linked together or plates that are linked together with little rings to join them. This one is done with what's called a living hinge, where you've got essentially, if you look at that top blue button, you've got 2 buttons of plastic joined with a little thin bit of plastic that allows it to bend. Now this was done purely as a fashion exercise, but you can start to imagine, depending where on the buttons you put the hinge, you can start to have materials that'll bend one way but not the other way. And you can start to think, well, could I use this, for example, for safety gear for the police or for firefighters, or sports people, a knee pad that'll bend one way but not the other, and start making protective gear with it. So it's not what it's being used for today, but you can start to see, and that's what's cool, is when, in this case, artists think of it as an application, you can start to think, well, what else can we use this for that might have applications beyond what it was originally thought of? And that is a very, very nice example of that. This is another fantastic example of complete assembly. So UAVs, unmanned aerial vehicles, so essentially model airplanes if you think of them. Typically an airplane like that is made up of several hundred components, maybe several thousand components. This entire airplane is made up of 4 components, excluding the electronics. You've got the wings with the ailerons built into the wings, all printed as one. And in fact, if you look at that top left picture, you can see the wings are hollow with scaffolding on the inside. So extremely lightweight, but extremely rigid. So you've got 2 wings, the fuselage and the nose cone, slide in your electronics, hook on the hooks that control the ailerons, and in 10 minutes you're ready to fly. That is a very, very nice example of that complete assembly in one go. And being able to have those moving parts means you don't suddenly need all the different parts to assemble the wing flaps and so on. I thought the next example is a nice one, mainly because you're in Sweden and bicycles are so popular here. This is the Aerospace Innovation Center in Bristol. Now this is not new, this is probably about 4 years old, 5 years old, and it's a complete 3D printed bicycle. So again, a nice little example, very appropriate for Sweden, I thought, but it would be interesting to now start doing something that maybe looks a little bit cooler than this, or maybe is a little bit lighter or feet. This was done to show how strong the materials have become, rather than designed for optimization for 3D printing, but it is still a very, very nice example. And from Canada, the Irby, by a company called Core Ecologic, which is the first 3D printed car. Now again, this is about 4 or 5 years old, but they're now apparently about to take it into production. And it's a car where the entire body is 3D printed. Now, I'm not entirely sure whether I'd like to be caught in an accident in this thing, but you can sort of see where it's going in another year or 2 or 3 to be able to have entire 3D printed cars. Now, since then, there's been quite a few other people working on 3D printed cars, including the SAE race car competition that a lot of universities have. There's the DB5 in the latest James Bond movie, the one that they blow up and shoot full of bullet holes at the end, that was 3D printed as well. So, countless examples of using this for automotive applications. Now we start to get, to me, the ideas, I guess, the things that make 3D printing really great. So, yes, complexity for free is fantastic. Being able to mass customize is fantastic. Being able to print complete products is also great. But here we're starting to talk about the ability to try ideas out at very little risk. So typically, if you want to take a product to market, you're talking about many, many tens of thousands of dollars. Call it 50,000 up to 500,000 to 1 million kroners to get your idea to the market. You've got to pay for tooling costs. Very, very expensive. Suddenly with this technology, you can get your product to market at very, very little capital outlay. Yes, the product is more expensive, but the capital outlay is very, very minimal. So what this means is inventors who previously had a great idea for a product, maybe it wasn't great. There's an 80% chance it probably wasn't great. But for those 20% that are good ideas that maybe could make it to market, you'll probably find 80% of those don't make it to market just because of the costs of getting it to market. So suddenly there's an opportunity for this. This was a product that we did for a New Zealand company called Galantai Plastics. And they had an idea for an innovative new, it's a soap dispenser. So it doesn't look like much here, but we produced 100 units for them for $2,000. So call it $20 a unit. Now, in manufacturing cost, that is relatively expensive. But in terms of getting an idea and testing it to the market, it's absolutely nothing. When you think of just the tooling for this product, is probably, I'm talking dollars because I'm still learning to convert to kroners, but you're talking $50,000 to $80,000 for the tooling for that. Now suddenly for $2,000 they can actually test it, make sure it's right for the market, and then decide to change it or go to market for it. So a very, very nice example of that. This is a guy called Scott Summit in the United States, so a company called Bespoke Innovations. And this is an interesting project, not just from the product itself, but also from the social implications of it. There's a problem around the world with amputees and prosthetics, that prosthetics tend to hinder an amputee's life. Essentially, to put it as politely as I can, prosthetics today are ugly. And if you have a prosthetic, you tend to not want to go out because you don't want people to see that you have a Frankenstein-looking thing on your arm or on your leg. So Scott Summit thought, can we take prosthetics and make them objects of beauty? So instead of making things that are ugly, make things that are beautiful. And he started a company based around this, making what he calls prosthetic fairings, where he makes clip-on bits that you can clip onto your prosthetic to make them into things that are relatively beautiful. And he's found this is actually having a social impact. Now amputees, it's hard to say that they're proud of it, but they tend to show it off a lot more. And I know he told me a story of one guy who had tattoos on his left calf, but his right leg was missing, and they printed him out a fairing with the matching tattoos on the right side. So just nice examples of getting people back to as normal a life as they can have. And you can see some beautiful, titanium, leather-tooled covers, some really, really beautiful fairings for prosthetics. So a very, very nice example of that. So this brings me to the guitar slowly. So this is back to 2011. The Economist did a story called Print Me a Stradivarius, where they took the blueprints of a Stradivarius, CAD'd it up, and 3D printed a violin. And that's the violin, very dark on the bottom there, but that's the violin coming out of the powder. So it's a powder-based process. And that's coming out of the powder. And just so you can see that it is a real violin, in this case, the entire violin is 3D printed except for the bridge and the tailpiece. Everything else is 3D printed in one piece. So, and the strings, of course, are standard strings. But surprisingly, it sounds like a violin. Apparently, it's a little bit heavier than a regular violin because of the material. But another thing you need to remember is this was done as an exercise to show it could be done. Ideally, you want to redesign the violin for these materials, what they can and can't do to change the acoustic properties of it. But that wasn't the object of this exercise. But this story got me thinking, I've been using it since the mid-90s, and I've been seeing the technology get better and better and better year by year. And I was actually at my parents' place in South Africa, and I was bored, I didn't have anything to do. So I thought, oh, maybe I'll design a guitar just to see if it's possible to 3D print an electric guitar. And when I got back to New Zealand, I 3D printed the first one. And I now manufacture an entire range of 3D printed guitars. So in fact, the one on the top right there was a spider version of that. Now the reason for the shape is not because I think it's a cool shape, but that's the biggest shape I could print in the printer I had in New Zealand. So I was restricted by the shape. But the first one I designed was the one on the top left there, and I got an American to print them for me. And I've now sold about 36 of these guitars around the world. And again, nice example of being able to start a business at no capital expenditure. I didn't have to lay out tens of thousands, hundreds of thousands of dollars to get the business started. And an example of mass customization, because every one I make, I custom make for the musician. I can put, from silly things to putting their name on the back to shifting the weight around. Because I'm working with a digital model, I can shift the weight around to give them the balance they want depending on the style of guitar they're used to. And the one on the bottom right, which is one of the more recent ones, just to show you, for those of you who haven't seen it over there, all of the gears and the pistons turn. So it's called the steampunk. And again, all printed in one piece. So a nice example of working assemblies. And afterwards, feel free to flick the little bottom switch on the bottom on the one out there, and you'll see it works. And surprisingly, they don't sound too bad. They actually sound pretty good. So yeah, very, very nice example of being able to take an idea and actually turn it into a business without actually having to risk too much. And just some more recent ones. Again, they're on the container, so not quite here in time. This was after I did the guitars. I started a partnership with 3D Systems, one of the manufacturers of the 3D printer. And last year for Euromold, the big show in Germany, they said, oh, we want a whole 3D printed band. So I did a 3D printed keyboard for them, and I did a 3D printed drum kit. Part of one of the drum kits is what you see under the table over there. I've got to finish assembling it once my container arrives. But so, again, it sounds like a drum kit. Surprisingly, the acoustic properties are not too bad. And then the final one, which is sort of work in progress underway, a 3D printed saxophone. So this one's not finished yet. I've got to finish assembling it when it arrives in hopefully another week or two. And I've played one note on it because that's all I can do without having the keys. And again, it sounds not too dissimilar to a saxophone. It sounds sort of in between a clarinet and a saxophone. So interesting, but it'll be interesting to see what it sounds like when it's fully assembled. So, again, being able to try out ideas at no risk. And to me, one of the things that makes 3D printing different from an innovation point of view, most innovation tools out there are mental tools. They're ways of thinking differently. 3D printing is actually a physical tool that allows you to innovate in different ways, and that makes it quite different. And suddenly people start making it. And one of the other big advantages in terms of innovation, and the one on the bottom is actually quite important, is that suddenly children are starting to make again. Children see a 3D printer and they immediately understand, maybe they don't understand how it works, but they immediately understand what they can use it for. Ooh, I can make new toys, I can make a new leg for my broken whatever. So suddenly we're seeing children starting to make again. Whereas in the past 15, 20 years they've been drifting into the digital world, now they're drifting back into the physical world. And that is really, really rewarding to see when you... And now there are a lot of primary schools around the world that are starting, from primary level and secondary school, starting to have 3D printers for kids to start making again. And that is actually amazing in terms of how it stimulates innovation. So really, the next few examples are examples of stimulating innovation. Now that's only different from the previous category in that the previous category was about making money with it. This is not necessarily about making money through 3D printing. And this is a nice example of an American eagle that lost its beak. So they catted him up a new beak, printed it out, glued it on, literally glued it on with epoxy resin, and gave the eagle a new lease on life. So no money to be made here, and it's not impossible to do this the old-fashioned way. You could have carved it by hand with hand tools, but it probably would have been too difficult, so you probably wouldn't have. Where suddenly with 3D printing, if they can get it into a CAD package, hit the print button, and a few hours later they're ready to go with it. So a very, very nice example of that innovation, I guess, for free. The next one is even stranger. This is a guy called Miles Lightwood in the United States, and he did something called Project Shelter. And over the last 5 years, the patents on a lot of this 3D printing technology has expired. So suddenly we've seen a whole range. There's about 130 different desktop 3D printers that have come out in the last few years, where for $1,000 to $2,000. So we call it 3,000 to 5,000 crowns, you can now buy a desktop 3D printer at home. So this has created a whole new movement around the world called the maker community, where people like the geeks of the world who like to make things. So he did it just for fun as a project, something called Project Shelter for hermit crabs. Now hermit crabs, when they lose their shell, will move into any available container as a new home. And there's a picture there on the left of one moving into the cap of a Coke bottle as a new home. So he decided just for fun to see what happens if I print a hermit crab shell. It's also quite a funky shape in terms of CAD to do it up. He printed them out, and if you go to his website, you can see there's an aquarium with a hermit crab investigating around the shell and then moving into the hermit crab shell. And he's now started a movement around San Francisco with a maker community in San Francisco. Whenever the printers have got downtime, they print hermit crab shells and throw them into the sea for the hermit crabs to move into. So there are some environmental questions there, yes, but it's still a nice, innovative idea. They do print them out of biodegradable plastic. Still some big questions there, but technically they will dissolve at a time. But again, a very, very nice example of thinking differently, and that's something that this technology gives you. Another nice example, Virginia Tech. They now have a vending machine at Virginia Tech where you can walk up with your memory stick, plug it in, and it'll print you out your parts, and you come back 15 minutes, an hour later, and your parts have been spat out on a little conveyor. Very, very nice idea. So again, just ways of students accessing this technology better and better. So this is something at Massey University, my previous university, where in the lobby of the building, we had about a dozen of these desktop 3D printers that were completely open access. Anybody could walk in and use the machines. We had the fourth year students managing the lab, fixing the machines, because always there were at least half the machines that were not working, and they had to be maintained by the students. Probably half of what they printed were iPhone cases, but there's nothing wrong with that. They learn a lot from it. But absolutely incredible in terms of getting students from engineering and students from art and students from business and social science suddenly in the same environment, talking to each other, helping each other, had an incredible impact and really, really good. So we have a plan to do the same thing here at Lund, to have an open access lab for people to come in and collaborate, to work together, to share ideas. And that, I think, is going to be very, very beneficial to the university, and it's going to be very, very exciting. So the plan is we'll have two labs. We'll have the open access entry-level desktop printer lab, and then we'll have a more advanced lab with the more expensive machines on which we have to control material a little bit more, which is one of the things that's actually quite important, because some of these technologies are still relatively expensive, both in the machine and the running cost. But one other take-home message, I guess, there's been a lot of confusion from the media. They talk about little desktop 3D printers for $1,000, and they talk about $1 million machines as if it's the same machine, and it's not even remotely close. So a very, very important take-home message, there we go, is the difference. The best example I can think of is a kid's pedal car compared to a real car. Both are absolutely fantastic. To a 6-year-old, the pedal car is the best thing in the world. But it's not the same as the real car. And it's exactly the same. These desktop printers are absolutely fantastic. I think everybody should have one. I think everybody should have one at home. But it's not the same as a $500,000 machine that can make production parts. And often when you look at the media, they'll show one of these $1,000 desktop printers, and they'll have a picture of my guitar next to it. So people are thinking, ooh, I'll buy one of these $1,000 machines, and suddenly I can make gold jewelry or things that you cannot make. So it's important to differentiate between the two and see the difference between them. So really that's one of the media problems in terms of how these technologies work. Supply chain. And this is why people are referring to this as the third industrial revolution, or the next industrial revolution. Because you can make parts on demand as and when you need them. This is going to have an effect on our supply chain over the next few years. So pre-industrial revolution, you were the supply chain. So if, for example, I wanted to make a chair, I was the supply chain. I made the chair myself. Possibly, I might have gone to barter with the blacksmith and exchanged some eggs for some nails, maybe. But the supply chain was the village. Maybe if I made a lot of these chairs, I could sell them to other people in the village. Even the village on the other side of the hill typically was too far. Today, you look at the same supply chain. I want a chair. I go to Klaus Olsson, one of the Swedish stores. I buy my chair. They get it from a warehouse in Helsingborg or wherever it might be, who get it shipped in from a warehouse in Guangzhou, who get it trained in from another city in China, who get materials. The supply chain is enormous. Typically, the cost of the product is 10% of the real price you pay for it. The rest of it is in the supply chain and all the middlemen who add on 20%, 40% surcharge all the way through the chain. So you can start to imagine there's now people who are conceiving, and this is already happening around the world now, where when you need a product, when you need a new chair, you go to the equivalent of your local 7-Eleven with your memory stick and you say, print me one of those. They print you out the chairs, you go home with your chair. And that is the supply chain. It's already happening. FedEx, DHL, Staples, which is the big warehouse chain in America, are now doing 3D printing as a service. The idea is for DHL is instead of having your plastic Lego toy You buy it in Los Angeles and you DHL it to New York. Instead, you now just email the file across, they print it at the other end, ready to go, so you don't ship it around the world anymore. Now, we're not there yet. We're still a long way away from this being a reality, but there are people working on this today. So this will have a major impact on the supply chain at some stage in the near future. And it's amazing that it's already starting. And there are people predicting that at some stage we will go back to the pre-industrial revolution model, where we will have a 3D printer at home, and whenever we need a new chair, we'll print it out on our own 3D printer at home. Personally, I don't think we'll ever get there. I think we'll keep using that as a goal. I don't think it's practical, firstly. I think there's multi-materials. The chair is made up of metal and wood and cloth. Whether the technology ever reaches that level or is ever affordable to get to that level, I don't think so. But I do predict, and it's already happening now, that we will all have 3D printers at home to make things like toys. Within the next year or two, there will be 3D printers available for, let's say, $300 to $500. Call it 1,000 to 1,500 kroners. That's not a lot of money. That means it'll become the favorite Christmas present, and everybody will buy them for their kids with the purpose of making toys, making Lego blocks, making dolls, making things like that. And for that, the application is perfect for that. And that's not when it will happen. It's going to happen very soon, within the next few years. So that hopefully gives you a quick taste on what people are doing with these technologies today. The next few slides are where it's heading in the very, very near future. Things like printing houses, food printing, tissue engineering, bioprinting, printing body parts. So the first one, this is from the University of Southern California, Proshkoshnevis, who's talking about 3D printing houses. Now this is an animation. I might just dim the lights down a tiny little bit, possibly, if I can. Ooh, not too much because it'll affect Robert's video. The principle is very, very simple. You have a nozzle squeezing out, like toothpaste, it's squeezing out toothpaste or icing for a cake, and layer by layer. So this will give you the principle of 3D printing for those of you who haven't understood that layer upon layer yet. So this is the first layer nearly finished, and it's just squeezing it out, and it jumps up and does the second layer. And layer by layer by layer by layer, it's building up the house in this case. Now, of course, you have a problem with this technology. When you get to the top of the doors, you can't print in empty air. It's just going to collapse. But you will notice on the right-hand side, you've got another green robot, and on the ground, you've got a bunch of yellow beams. So when it gets up to that level, you'll see the robot go pick up the beams, place them on the doors, on the lintels, just so it's got something to print on when it gets up to that level. Now, the principle is actually incredibly simple. So here we go now, it's picking up the beams, and away it goes. Now, the general idea is you could print a whole housing estate with 10, 15, 20 houses. Now, we're not talking about developing country houses. This could be luxury housing where you go online, you change your design, you add windows, you add rooms, buy now. The next day, this truck rolls up to your site, sets up the machine, and prints you out a house. We're not there yet, but I'll show you where we are now. So this is the next little video clip is in his lab. This is a little baby machine built by students in printing out of clay. So it's just squeezing clay out of a nozzle, and layer by layer by layer, it's going to build it up. In this case, it's doing a three-leaf clover shape. And you'll see now, so it's about to come back to the bottom of the first one, and it jumps up, and it starts the second layer. And it's just squeezing out that clay. In this case, here we go, that's a second layer. In this case, it's only smoothing out the outside, because the inside would be where the insulation or the wiring or other things would go. But if you go to his website, there's plenty of other videos showing it smoothing or doing domes, or stepping into new domes. And now we're going to jump to a bigger machine in his lab, printing out in real concrete, printing out full walls, and so on. So Proshkoshnevis, he's been working on it for about over 15 years now to get the technology ready. And he's now able to print walls and beams with reinforcement. So very, very impressive from an engineering point of view. But where things went suddenly, so he's predicting that by the time the technology is ready, 48 hours to print an entire house. Now you think about that from the effect this has on the building industry. It's going to be huge, but it gets worse. About 3 months ago, out of China, 10 houses in 24 hours, 3D printed. Now, how much of that is true, we don't quite know. There's a bit of media spin in there, and I can guarantee you that A, it was more than 24 hours, and B, there's still a lot of work to do with wiring, with all the other things to make a house a house. But in terms of the technology is exactly the same, and you can see there the layers of material plus reinforcing material in between to give them the structural strength they need. Again, that is actually almost scary, being able to print 10 house in 24 hours. It doesn't matter if it's not 24 hours, even if it's a week, it's still frightening. And you think about what is this going to do to the building industry? It's a bit like in the 70s when they brought in automation in Japan with all the factories. It didn't mean all of Japan was suddenly made redundant overnight. It means you now have to retrain your workers to build the robots or to build the 3D printers or to design or into different career choices. But what it's saying is that we need to be thinking about that today to be able to be ready for when the technology does hit the road for real. This is another interesting one. So this is inside your bloodstream, and you have these little nanobots running around inside your bloodstream, keeping it clean, keeping you healthy. So this is very much in the science fiction realm in terms of what they can do today. But the idea is nice. And in this case, the concept is the little robot is powering itself off what it's eating. But just to show you where they are today in terms of size, on the bottom left there we have what's called the nano bull. So it's a 3D printed Spanish fighting bull. To put it in perspective, it's 1/10 of a human hair in size. That gives you an idea. The fact that you need a microscope to see it tells you how small it is. It's actually incredible. And here, a bit harder to see, we have a suction cup, a spring, and a frame just off the picture. This is the first, again, this is about 4 or 5 years old now. This is the first 3D printed micro machine. When you shine a laser onto this, the suction cup releases, the spring tightens, and it moves along. So it crawls along like an inchworm. So it's a very, very simple machine in the loosest possible sense of the word. But you can see we're not 1,000 miles away from being able to do more complex structures. And every year they're getting smaller and smaller and better quality and faster the machines. So it is only a matter of time before this kind of technology does exist. So that leads us on to sort of one of the more interesting areas, one of the more exciting areas, which is bioprinting.
And fantastic science, growing your own replacement parts in a lab.
This is the CBS Evening News with Katie Couric.
Every day in this country, people die waiting for a donor organ because there's a critical shortage. About 98,000 people are on a waiting list for transplants right now. Many of them will die before they get one. But now a new generation of researchers is changing that one cell at a time. And what they're doing is truly amazing. Wyatt Andrews goes inside this brave new world in our special series, Growing Miracles.
Body temperature. Right. That's for the same temperature as inside your body.
In what you might call the laboratory of the future, Dr. Anthony Atala is manufacturing body parts.
Actually, here you see a engineered blood vessel. You can actually see the vessel beating.
From blood vessels to muscle tissue, Atala and his team at Wake Forest University believe, in theory, anything inside the body can be grown outside the body. They've made 18 different types of tissue so far.
That's a heart valve.
This is an engineered heart valve.
A pulsing heart valve to be transplanted into a sheep.
When people ask me, what do? We grow tissues and organs.
You really are making body parts.
We are making body parts that we can implant right back into patients.
Once considered a Frankenstein fantasy, the field of regenerative medicine is on the verge of unimagined breakthroughs. Scientists believe every part of the body has cells capable of regeneration. All researchers need to do is isolate those cells and coax them to grow.
You're using heart cells in an inkjet printer.
Yes. In this lab, they're making the heart of a mouse. A heart they grew layer by layer by spraying the cells with a printer.
So your heart cell is programmed to make more heart tissue. Your bladder cells are programmed to make more bladder cells.
And it's Atala's work with human bladders that's truly on the frontier. In a clinical trial at Thomas Jefferson Hospital in Philadelphia, this patient is getting a bladder transplant with a new bladder grown from her own cells. Using Dr. Atala's regeneration techniques, her cells were isolated, multiplied, and seeded onto a biodegradable scaffold. 8 weeks later, her new bladder is in the operating room, ready for transplant.
Every day.
I mean, that is just incredible. I mean, that is exciting and frightening at the same time, being able to print body parts. So 2 main ways of doing it. The bladder, they print a scaffold. So it's a plastic scaffold that's printed, seeded with the cells, and over the next 6 weeks, as the cells grow into what they're supposed to grow, the biodegradable scaffold is slowly dissolving, and the other way is to print directly with the cells in a hydrogel, a gel to keep it together. And again, the same principle, as the cells form into what they're supposed to become, they become the organ. So today, this is happening today. This is not science fiction. Currently, it's relatively what you would call simple organs. So bladder, skin, valves, heart valves. So it's relatively simple, but they have just recently printed out liver cells, which last for, I think, 40 days is a break-even point, where once it's over 40 days, it becomes viable. So we're not that far away from being able to print the more complex organs. I'd like to hope within my lifetime we'll be able to print the more complex organs for when I need them. But, I mean, this is incredible, and this is happening around the world. Every country in the world has got university departments, research companies working with tissue engineering, bioengineering, bioprinting. But, you know, at the same time, when you talk to students, you start to think about all the ethical questions this raises. You know, and currently, I think we're at a stage where the technology's gotten ahead of the social implication side of things. I mean, to me, the ability to print out a new heart or a new liver, to me, it's obvious that it's a good thing. But, you know, should I be able to print myself a whole spare body to keep in the refrigerator at home just in case? That's where you start to cross into a gray area about ethics. Or you think about all the problems they have with Olympics, with Olympic cheats. Should you be able to print yourself out organs that were better than before? Now, to me, the answer is obviously yes, because I have no ethics. But I'm sure a lot of people would disagree. I mean, to me, yeah, Superman, why not? But, you know, there are a lot of ethical and social questions that this raises that we haven't even thought about yet. And to me, one of the interesting areas of research for the near future is, what is the impact? We talk about building houses. What's the impact going to be on the building industry, on architecture, bioprinting, all these things, on manufacturing? How's it going to affect it? So, like I said, very, very exciting area ahead. And again, from May 2013, just less than a year ago, a 3D printed bionic ear where they printed an ear with embedded electronics. Very, very interesting. It just shows you the range of research around the world that is going on in this area. And this is probably my near the end, food printers, being able to print out food. So this is the cornucopia project by MIT Media Lab. And the idea is simple. On the top left, you see a 3D printed food printer. And on top, you have canisters of vitamins, flavoring agent, coloring agents, the Soylent Green of the future, or whatever the base ingredient are. And from that, you reconstitute your food at a base level. We're nowhere near that yet, but there are people around the world working on exactly being able to do this. And currently, the most successful so far has been a company called Modern Meadow and Organova, where they've been printing meat. And last year, they had a TV program where they had some British chefs eating a hamburger that was 3D printed. And from memory, it was about $30,000 for the hamburger. So it wasn't a cheap hamburger, but it was, you know, the world's first 3D printed hamburger. But on a more basic level, there's a lot of work going on around with printing with food rather than printing food. Now, there's a lot of printers that are based on syringes, where you can print with anything you can put in a syringe. And we had one of these in New Zealand, and it's now coming to Sweden. The first thing you do when you get it, you put some icing sugar in it and some chocolate in the other syringe, and you print chocolate flowers or icing sugar things. And here's an example from, again, Japan, where they had the Fab Cafe in Shibuya. They had a Valentine's Day promotion where you could buy a box of chocolates with your girlfriend's head printed in the chocolates. Again, not entirely sure it's a good idea or not, but yeah. And we have the Eat Your Face machine from the MIT Media Labs, again, printing with chocolates. So some nice ideas. And all going well here, we'll be getting a machine by 3D Systems called the Chef Jet, which allows us to print some more sophisticated cake toppers, 3D printed candy, different machine, but you can print noodles, you can print pasta, you can print pizza. So printing with ingredients is actually relatively simple to do and is being done today. The bottom line, the food is a little bit more high-tech and not quite as advanced yet, but it is coming. You know, it's not a matter of if, it's a matter of when, and not that far away. And in this case, of course, the cutlery is also 3D printed. Why not? I mean, yeah. So, hopefully today I've given you just a little bit of a flavor of what 3D printing is today, a bit of what it's being used for today, and just a very small glimpse of where it's going in the very near future. And possibly where I'll leave you, which is the conceptual one, where one day at home we may all have these machines at home, where when we need a new toothbrush, instead of going down to the local ICA or the co-op and buying one, we'll feed our old one in one end. It recycles all the materials. Of course, we've got data entry where we can scan our hand or our mouth or put in our favorite color preferences, and it prints us out a new toothbrush in shocking pink with a Hello Kitty logo on it and medium hard bristles, just the way we want it. And this is something that could maybe happen one day. Now, whether it ever does, we don't know. Whether the economics makes sense, we don't know. Whether the social side of it makes sense, we don't know yet. But there is research around the world going on that. So, basically, final take-home message is 3D printing is absolutely fantastic. I would encourage all of you, once we've got the lab set up, it looks like it might be in the Navet building, I think, over there, but we don't quite know yet, but it's going to be open access for anybody to come and use 3D printers and play with them and share ideas and collaborate and work together with all the different disciplines. So I would encourage all of you to have a play with it. I would also encourage all of you to buy 3D printers for home because they are pretty cool. But these will be the desktop ones, the nice, cheap, and cheerful ones, but they're great as idea stimulation tools. So with that, I'm happy to hand it over to you guys if there's any questions or discussion or thoughts that you guys have. So over to you. Thank you.